Amazing events are occurring in our solar system. Occasionally we have the good fortune to receive visitors from the farthest reaches of the universe. And guess what? One of these guests is making a return. Oumuamua suddenly showed up again and is now heading toward Earth. What does this portend for the future of our solar system? Let us find out. Hello and welcome to Zeey. If you are new to the channel, hit the subscription button so you don't miss future updates. Oumuamua, as it was dubbed by astronomers, was quite unusual because it possessed characteristics of both an asteroid and a comet. Comets and asteroids are typically pushed away by gravitational interactions during planet formation around stars. When initially detected, Oumuamua was classified as a comet. However, astronomers began to question this classification because the object lacked the characteristic tail of gas and particles that comets typically produce when heated by the sun. This led to various hypotheses among scientists. Some hypothesized that Oumuamua was either a rocky asteroid or a novel type of interstellar object. Others argued that it could be a planetesimal, an asteroid fragment ejected from its original system by gravitational forces. There was even speculation that it was a zombie comet or a monstrous, extremely fluffy aggregate composed of loosely bonded dust grains left behind by a comet as it approached the sun and disintegrated. You may ponder why there is such a fascination with comets. Comets provide valuable insight into the early phases of the evolution of our solar system. They have preserved a snapshot of our solar system's formation. Consequently, researching comets is analogous to peering into the past and gaining knowledge about the early formation of our solar system. Planetary systems interacting with interstellar space can propel space pebbles on long-distance journeys. Oumuamua, an interstellar object that travels through our solar system, is believed to be a comet by the scientific community. This conclusion is based on its higher than anticipated velocity, which cannot be explained solely by gravitational forces from the sun. It is believed that, like a comet, Oumuamua emits gas and dust-generating thrusters that propel it forward. Intriguingly, Oumuamua is approximately 10 times more reflective than comets from our solar system, possibly as a result of surface dust being blown away by the outgassing process, disclosing reflective ice beneath. The possibility that Oumuamua is propelled by jet-driven motion has piqued the interest of astronomers and SETI researchers, who have searched for technological signals from the object. In spite of 2 dedicated campaigns, no response has been detected. Avi Loeb of the Harvard-Smithsonian Center for Astrophysics and co-author Shmuel Bayali proposed an alternative theory positing that Oumuamua could be a very thin and light sail propelled by photons of sunlight. Loeb hypothesized that Oumuamua could be a discarded piece of space debris or, more intriguingly, a deliberately dispatched vessel exploring our cosmic neighborhood. Avi Loeb's assertion, while met with skepticism by some scientists, highlights the significance of contemplating valuable theories rather than outright rejecting the possibility of extraterrestrial life. Let's now investigate how Oumuamua entered our solar system. This celestial object was discovered by the Pan-STARRS 1 telescope at the University of Hawaii. It had already completed its orbit around the Sun and was preparing to leave our solar system. For approximately 4 months, astronomers from around the globe utilized various telescopes to observe Oumuamua until it became too faint to track. There is something about this phenomenon that has left scientists baffled. Oumuamua has reappeared and is now heading toward Earth. Scientists were perplexed by the fact that Oumuamua did not fit neatly into existing scenarios. Although it resembled asteroids, which are typically propelled by gravitational forces, it accelerated as it traveled. This acceleration suggested the existence of a force other than gravity. Similar to comets propelled by the evaporation of gas and dust near the sun, the object appeared to experience a propelling force. In addition, the expelled material altered Oumuamua's trajectory, slightly distinguishing it from asteroids and planets. Oumuamua was not a typical comet because it lacked a tail and the gas and dust envelope known as a coma. As a result, its arrival sparked debate among astronomers, heightening scientific intrigue as various models arose to explain its astounding velocity. These models suggested that the object may have extraordinary chemical properties. 2 scientists worked together to verify their hypotheses concerning the acceleration of the interstellar comet Oumuamua. They proposed a theory positing that Oumuamua is a water-rich comet traveling through vast interstellar space. The comet's reddish hue resulted from exposure to radiation, which caused the formation of hydrogen within it. Previous research suggested that ice could transform into molecular hydrogen, suggesting that a comet's structure could contain hydrogen bubbles confined within the ice. The scientists hypothesized that when Oumuamua was heated by the sun, the confined gas in the bubbles would be released as a spray in the shape of a fan, propelling the comet. This explanation could explain the peculiar behavior of Oumuamua without necessitating exotic chemistry or physics. It also explains why the comet does not have a dusty stupor surrounding it. Observatories such as the James Webb Space Telescope provide the opportunity to learn more about comet formation in other planetary systems and increase our understanding of these enthralling celestial objects. With the assistance of the Vera C. Rubin Observatory in Chile, which is scheduled to open in 2025, astronomers anticipate discovering a number of interstellar comets like Oumuamua each year. The study of these comets from other planetary systems can shed light on their characteristics. Comets and asteroids in our solar system have, surprisingly, taught us more about planet formation than planets themselves. If the Rubin Observatory's Legacy Survey of Space and Time program had been operational before the passage of Oumuamua, we would have been able to detect it much sooner. Although it is impossible to study Oumuamua up close, scientists aspire to study future interstellar objects. The Institute for Interstellar Studies has proposed Project Lyra, which aims to use advanced propulsion technology to investigate interstellar objects. If the mission launches in 2028, it may be possible to catch up to Oumuamua in 26 years using a complex Jupiter-Oberth maneuver. Soon after the discovery of Oumuamua, the Initiative for Interstellar Studies I4IS launched Project Lyra to investigate the possibility of dispatching a mission to Oumuamua using current or near-future technology. Since then, the I4IS team has explored the use of nuclear thermal propulsion, NTP, and a laser sail craft similar to the breakthrough Starshot concept which seeks to reach Alpha Centauri in 20 years. In their analysis, previous proposals for reaching Oumuamua with near-future technology proposed a solar Oberth maneuver or SOM or the sun diver concept, which utilizes the sun's radiation pressure to attain high velocity. However, this method requires enduring intense heat by approaching the sun as closely as feasible. At the heart of the solar Oberth maneuver or SOM and other Oberth maneuvers is the gravity assist technique, which has been used for solar system exploration since the early 1970s. This technique utilizes the gravitational forces of three bodies: the spacecraft, a second body, which is typically a large planet that provides the assist, and a third body that controls the trajectory of the spacecraft. Particularly, the SOM relies on three distinct velocity variations, or impulses, to leave the solar system. These stimuli include increasing the spacecraft's distance from the Sun at the aphelion, slowing down to approach the Sun, and obtaining a boost at the perihelion, the point closest to the Sun where the spacecraft travels at its fastest. Theodor Edelbaum devised the concept of the three impulses in 1959, but the term SOM is still in use. This technique is essential for catching up with an interstellar object that has passed perihelion and is now moving away from the Sun. When approaching the Sun, the Parker Solar Probe demonstrated the need for a robust thermal shield that can withstand extreme heat and radiation. A heat shield for Project Lyra would vary in size and mass, but it would considerably increase the light sail's mass. A mission to rendezvous with the asteroid Oumuamua or the comet 96P/Mach has the potential to yield significant scientific insights into distant star systems. These missions are cost-effective and have the potential to yield significant discoveries. Recent research has cast light on the distinctive characteristics of interstellar objects such as Oumuamua, which distinguish them from typical comets due to the absence of carbon and cyanogen. Scientists hypothesize that these objects may contain a nucleus derived from primordial and interstellar sources. Despite the inherent difficulties, scientists are optimistic about the discovery of additional interstellar objects following the discovery of the first interstellar comet and the detection of meteorites from other star systems. In August of 2019, amateur astronomer Gennady Borisov discovered the comet known as C/2019 Q4 alias Borisov. Additional observations revealed that its orbit was hyperbolic, implying its extrasolar origin. With a substantially higher eccentricity and a tilted orbit, the comet's surface properties were likely shaped by cosmic ray bombardment over millions of years during its interstellar journey. With the exception of perihelion, its limited activity and distance from the Earth make it difficult to observe. Although satellite observatories such as SOHO can provide some insight, many mysteries surrounding the comet, such as its origin, remain unsolved. Borisov attained perihelion on December 8, 2019 at a distance of approximately 2 astronomical units from the Sun, and it made its closest approach to the Earth on December 28, 2019 at a distance of approximately 1.8 astronomical unit. Comet 2I/Borisov is moving away from the Sun and will ultimately leave the solar system. It is an intriguing interstellar traveler with a hazy envelope of gas and particles known as a coma and a tail formed by material propelled by the solar wind. Similar to other comets in our solar system, the nucleus of this 1-kilometer-wide comet was only visible through large telescopes, attaining a magnitude of 15 in late 2019. Organic compounds and prevalent cometary constituents, such as water, carbon monoxide, and cyanide, impart a reddish hue as determined by spectroscopy. Carbon monoxide levels in 2I/Borisov are significantly higher than those of typical solar system comets, indicating an extremely frigid origin. The study of this comet contributes to our understanding of diverse planetary systems and of Oumuamua, the first interstellar visitor discovered in 2017. While we won't see 2I/Borisov again, technological advancements in the future may reveal other intriguing extraterrestrial objects. Alright guys, this video ends here. Thanks for watching. What are your thoughts? Please tell us in the comments and don't forget to like and subscribe.